Hello there, my name is Aiden, and I am a field applications engineer with InPlay. I'm going to be covering in this video some of the features we have changed in the NanoBeacon config tool regarding the advertising set settings. So we have an excellent series of videos available on our YouTube channel, which already covers the majority of what is in the config tool, but over time, updates come along and some things change. So I'm just going to be walking through this briefly and then focusing more on some of the changes or, recent additions we've added on. So as normal, once you load the NanoBeacon config tool, you have your three advertising sets here. All the advertising sets are essentially the same settings available. Of course, you can enable, disable, however you'd like. So when you're editing an advertising set, the first page you will see is the advertising data. This is how you determine what advertising data format you'll be using. Of course, we support iBeacon, so you can have your UUID, your major, minor, measure TX power level. Eddystone format, another basic one. So UID frame, EID frame, TLM frame, and then of course, whether you're doing measure TX power level here. And then most commonly a custom data format, so this is how the user might define their own data format. So you can include various different options in this. So this can include the device name, the TX power level that is being transmitted. This is a data that is on your payload here. The actual transmit power level of the device itself is under global settings transmit, and you can pick which power level, which dBm. But when editing an advertising set, you can also advertise a value which shows to the receiver what the device claims to be advertising at. So this could be 0, whatever dBm you're using. Manufacturer specific data. So this is a pre-formatted data format, which basically follows the BLE manufacturer specific data, but leaves what data that is up to the user. You can hit edit here, go through these options, and you can choose and add whatever you'd like. We have a couple different things here. So, the voltage, internal temperature, one wire count pulse interface, GPIO status, GPIO edge count, ADC channel information. We have 4 of those. Any of the 3 I2C slaves, on-chip timestamps, advertising count. You can read from internal registers, generate a random number, generate a static random number, encrypt raw information, encryption salt and the auth tag, your own customer product ID, which is sort of like a MAC address that you define, a Bluetooth device address, or a character that is UTF-8 encoded, or you could just type raw information into this. So for example, here I just have 2 bytes, 0, 1, and 0, 2. So for now, I'm just going to add voltage and move on. We also have user-defined data. If you go in here, this is basically the same menu as the manufacturer-specific data. However, this does none of the formatting of like the preamble for you. So this is if you're doing your own sort of custom stuff, your own custom IDs, or whatever you'd like. And if you're doing encryption, we have these data encryption settings here. You can choose which of the 3 keys is being used, the nonce salt source and the nonce counter source. Okay, so moving on, advertising parameters. This is a section we have made some changes to since the last set of YouTube tutorial videos that we have on the NanoBeacon config tool. So covering briefly the advertising interval in milliseconds, your PHY selection, whether you're using a standard 1 meg PHY or LE coded PHY for the longer range. If you're using constant tone extension, this is for angle of arrival applications. If you're changing or increasing or lowering the advertising random delay, which advertising channels you are transmitting on. And then this is where we made some changes, is we now have the option to do a static address and a public address. So for the static address, we have a couple different sources. You can have it generated by the PC tool. That refers to the NanoBeacon config tool GUI here. You can have it typed in by user input. So you type into this box here under public address, as indicated by the arrow. And then you can also have it randomly generated when the chip cold boots. A cold boot is when the chip wakes up from a state of which it had no power. So this would have it change basically its static address every time it is power cycled. So sometimes this is useful, sometimes this isn't. So If this doesn't work for you, you could also do it generated by PC tool, in which case it would stay static even throughout cold cycles or power cycling, right? We also have a public address, which is also typed in manually. And then we have a random address. This can be non-resolvable, as in some receiver isn't able to resolve it, which makes it very difficult to track the Bluetooth device based off of its address. Since it is non-resolvable and encrypted, it will be changing at a constant interval. And then private resolvable, which is if the receiver has the key, one of these encryption keys, it would be able to resolve this address and identify the Bluetooth device based off of its address here by resolving it. Okay. In advanced advertising, we have these options to, sort of do your own sort of custom formats here. So, for example, you can exclude the Bluetooth address from advertising. By default, this is included, per BLE specs. But if you're doing your own sort of definition here, you could change this. Also, enables you to do custom access addresses or custom PDU headers. In advertising mode, we have continuous mode, which just means as soon as the device is applied power, it will advertise at this continuous periodic interval. Then more interestingly, triggered advertising, you have the trigger event count, which is how many times the device advertises at a certain interval once triggered. We have this box here that you can check called trigger event will reset trig advertising event count. So without this checked, it will do, its first advertising event, then its second, then its third, then its fourth, then its fifth, then its sixth, and then stop. However, if this is checked and a trigger happens again, it will restart that count. So it could do first, the second, the third, another trigger happens, and then it goes back to 1 until 6 is completed without a new trigger refreshing the number. Single trigger means it will only happen once, and no future or subsequent trigger will cause the device to advertise. Recurring trigger means it can be triggered as many times as needed. And then advertise indefinitely after first trigger means that once you trigger it, it will basically act as a continuous. It's basically going until it runs out of power. For trigger sources, we have sensor trigger sources. So this could be something like the on-chip, temperature, on-chip voltage. It also come from the ADC channels or the I2C sensors. You have this triggered check period, which says how often the device wakes up to check its sensor trigger sources to see if it needs to advertise. And then for each trigger source, you have a low version, so a low threshold if it's below this value, or a high version, where if it's above a certain value, that's when you trigger. And GPIO trigger sources, you can use any of our GPIOs to trigger an advertising event. And I will cover both of these in a bit more detail in just a second. So I'll go ahead and just leave this as continuous for now, so I can keep editing other sections. So back at this default page, you can go to Global Trigger Settings. And this is where you could choose those different trigger sources and also assign their low and their high thresholds. So the sources will be in this drop-down menu here. So as I was mentioning, internal temperature, ADC channels, one-wire pulse counter interface, voltage, I2C slaves. You can see all the options in these different trigger sources. You can have any sort of combination there. So for example, if when it got too low, I wanted the device to start advertising a new advertising set once its voltage dropped too low, I could say its low threshold is 100. And then this is a raw unit, which is compared to the on-chip measurement units, which is under global settings here. You can see what scalar is being used to the on-chip ADC for the voltage. Okay, moving on to GPIOs. You have your GPIOs here that you can edit. If you want to use it for a trigger source, all you have to do is change it from default to input, decide whether it's going to be pulled up or pulled down. Its trigger source, which is high level, low level, rising or falling edge, and whether or not it's latched. When it's latched, it just basically means it is going to keep its state while asleep unless driven externally otherwise. So this would help prevent, certain glitches on the input, for example, changing its state when it's not meant to be. Okay, and that covers all the default of editing advertising sets. Of course, the newer information that we've changed since our last tutorial video was the Bluetooth device address settings here. So again, static, public, and random addresses, and then how you can assign those values. If you have any further questions, feel free to reach out to InPlay support or look at any of our tutorials on the YouTube or our GitHub. Thank you.